Hi everyone, this is Mrs. J, and today we're going to learn how to find the focus of a parabola. But first I have a quick warm-up for you guys, so please pause the video and give them a try. Alright, go ahead and check your work here. So here's that distance formula. If you forgot, it's the square root of x2 minus x1 squared plus y2 minus y1 squared. So it doesn't really matter which coordinate you consider the first or second. So I just use this as second and this is the first, plugged it in and simplified. So the first one, our distance is just 10. For the second one, our distance is the square root of 45, which can be simplified to 3 root 5. So we will be coming back to this distance formula today, which is why we included it in the warm-up. So in our last lesson, we learned many different forms of our quadratic functions. Today, we're going to get a little more in-depth into the formal definition of what a parabola is. So the more formal definition tells us that a parabola is the set of all points, so the xy coordinates in a plane that are equidistant from a fixed point, which we call the focus, and a fixed line, which we call the directrix. Okay, so to make sense of this, let's look at this parabola in the image right here. So you'll notice that this point right here, this is what we call the focus. So the focus is always going to be on the inside of our parabola. So if our parabola is facing up, it's always going to be actually directly above our vertex. If our parabola is facing down, it will be directly below. And we will also be working with horizontal parabolas. So if our parabola is opening to the right, it's going to be to the right of our vertex. And if it's opening to the left, it's going to be to the left. But notice it's directly in line with our vertex. So here's our focus. And then notice below our graph here, we have this horizontal line. This is our fixed line, and this is the directrix. It's always going to be perpendicular to our axis of symmetry. So for these types of parabolas that open up or down, our directrix will always be a horizontal line. If our parabola is opening to the left or right, our directrix will be a vertical line. So if I pick any point on our parabola, so here you can see they're showing this with 3 different points. If you measure the distance from that point to the focus, it should always be the same as the distance from that point to the directrix. So that single dash indicates that this line segment is equal to this line segment. Now let's look at this coordinate. If you measure this distance from the focus to that coordinate, it should always be the same as the distance from that coordinate to the directrix. And here's another example here. So this distance should be equal to this distance. So that is how a parabola kind of is formed. Any point on your parabola, this should be true. This distance should be equal to this distance. So today we're really going to focus on being able to indicate what our focus is and what our directrix is. So before we actually look at these general equations, we're going to see if we can actually derive our own equation of an upward or downward facing parabola. For this one, we're going to say that the vertex is at the origin, is at 0, 0. Our focus is right here. We're going to call this coordinate 0, p, so p can be any value. We're going to work with some coordinate on our parabola, which we'll just call x, y. And then we will call our directrix the line y equals negative p. So if you draw a vertical line to represent the distance from this point to your directrix, that point right here would be at x negative p, because our x value should be the same, and we know that the y value is negative p. So the definition, again, of our parabola is that every point should be equidistant to the focus and the directrix. So I know that this line segment should be equal to this line segment. So now let's find a way to describe these distances. Let's start with our vertical distance. Here, since they have the same x values, the vertical distance is really just the difference in y values. We will want to make sure that that distance is always positive, so I'm just going to put absolute values around it. And the distance between two values is just the difference. So we're going to subtract. We're going to do y minus negative p. Again, I'm just including the absolute values because it is a distance and we want to ensure that it is negative, or that it is positive. And then to define this distance, we're going to need to use our distance formula. So here we're going to do the square root of x minus 0 squared plus y minus p squared. So from here, our goal is to isolate y. We would like our equation to say y equals something. So the first thing I'm going to need to do is get rid of this square root symbol. So I'm actually going to square both sides. So when I square both sides, that's a different way of ensuring that this value will be positive. So it'll be y plus p squared equals x squared plus y minus p squared. So again, when I square this side, it just gets rid of this square root symbol. When I square this side, notice I put parentheses and I squared the entire binomial. I'm squaring the entire side. Now, since we want to isolate y, we will need to expand out these binomials. So that would give us y squared plus 2yp plus p squared equals x squared plus y squared minus 2yp plus p squared. And then again from here, we're going to keep isolating y. So one thing to note is that your y squared terms will cancel out, and I'm going to add my 2yp to both sides to make it 4yp. And then here we're going to have just equals x squared because our p squared terms will also cancel out. And then if I want to solve for y, I just need to divide both sides by 4p. So we have y equals 1 over 4p x squared. And this actually is the general equation for an upward downward facing parabola with a vertex at the origin. So I know this looks a little bit strange because it has that p value in here, but the p value is going to be crucial to helping us determine what our focus and what our directrix are. So notice that if our vertex is at 0, 0, p is actually the vertical distance to the focus and that vertical distance to my directrix. So that's how we're going to be using that p value. So again here, this will look familiar. This is what we just derived. These are the standard equations of a parabola with a vertex at the origin. So notice here, we have our upward and downward facing parabolas, which are represented by y equals 1 over 4p x squared. And again, p is that distance from the vertex of the focus or the vertex of the directrix. Now down here, this is a little different for us. We actually have horizontal parabolas. They have that horizontal axis of symmetry. So these will open to the right or left. Now if you look at that general formula, we're going to compare it to our vertical ones. You see that it looks really similar, except for this one, it says x equals and y is the variable being squared. So anytime y is the variable being squared, we know that we have a parabola that's going to open to the right or left. But notice that that distance from the vertex to the focus or the vertex to the directrix is still p, and we can pull that p value from this number. So whatever this coefficient is, we just set it equal to 1 over 4p, and that allows us to find p, which helps us place our focus and our directrix. All right, let's try one of these together. So here we're going to identify the vertex, focus, and directrix, and then we're going to do a super rough sketch of our graph. We're just going to really make sure our graph is opening in the correct direction. In terms of exact coordinates beyond the vertex, we're not going to worry about that for today. So first I need to make sure my equation is in the correct form. So I'm going to divide both sides by 8 because we need to isolate y. Now a few things we know right off the bat. We know that our vertex is at the origin. We don't have any transformations for these. And we know since x is being squared, it's going to open up or down. And since this value is positive, it's going to open up. So I'm just going to do, again, a super rough sketch. We're not worrying about exact coordinates for today. Now, I do need to figure out what my focus and directrix are, and that requires us knowing that p value. So remember, whatever is in front of x squared, this coefficient, should be equal to 1 over 4p. That's that general form that we derived. So I'm just going to set it equal to 1 over 4p. I'm just going to solve for p. And here we get that p equals 2. So since p is equal to 2, that tells us that our focus is 2 units away. It's going to be directly above our vertex. So from our vertex, I'm just going to go up 2 units right here. and that is my focus. So we can see that our focus is at 0, 2. Also, we know if we're starting at the vertex, if I want to go up 2 units, I would just add 2 to my y value. So that's how we get 0, 2. Now, P is also the distance from the vertex to our directrix. I'm going to go 2 units down, and then I'm going to draw in a horizontal. I'll use a dotted line for these, or a dashed line for our directrix. So notice this distance from the vertex to the directrix is also 2 units. Now let's define what that equation is. Remember, the equation, or the directrix is a fixed line. So this is the line y equals -2. Make sure it's a full equation, and we can label it on our graph. And there you have it. So again, the key to these problems is finding that p-value, because that's always the distance from the vertex to the focus is p, and the distance from the vertex to the directrix is going to be p as well. All right, let's try another one together. So first, I'm going to isolate x to get it into that general form. So here we know again that our vertex is at the origin. And in this case, our y variable is being squared. Since y is being squared, that tells us that our parabola will either open to the right or to the left. And since this value out front is negative, that tells us it will open in the negative direction, which is to the left. So our graph is going to look roughly like this. Again, it's just a super rough sketch. As long as it's opening in the correct direction for today, that's totally fine. Now we need to find that p-value. So I take whatever my coefficient is, which in this case is -1/4, and I set it equal to 1/4p. That's just our general equation. So we have -4 equals 4p, so p is -1. So since it's negative, that is telling us that we are going to the left to place our focus, and we go to the left 1 unit. So there's our focus, and we know that that focus coordinate is -1, 0. And again, we could start from our vertex, and if I want to move to the left, I just subtract 1 from my x value. And then I'm also going to go 1 unit to the right of my vertex, and this one is going to be a vertical line for my directrix. So remember, the directrix is always outside your parabola, the focus is always inside, and the directrix should never intersect your parabola, which is how we know it should be a vertical line for this type of parabola. Again, we are going to define what that equation is. It's a vertical line this time, so it's going to be at x equals 1. So now we're going to see if we can look at a picture of a graph and create the equation of this parabola. So the first thing I'm going to do is I'm actually going to look at it and determine the general form based on which way it's opening. So since it is opening down, I know that my x term, or my x variable, should be squared. So it's going to be this form. Now, since it is opening down, that's going to tell me that my p-value is negative. So to help me find that p-value, I'm not given the focus here, but I am given the directrix. So I know that this distance is always going to be p. So here I'm going to say that p is -3, again, because our graph is opening downward. And then I know that the vertex, the vertex is at the origin, so we don't need to worry about that. So all I need to do is substitute my p-value into our general form. So we have 1/, I'll put the negative out front, -1/12 x squared. So again, this is kind of a matter of deciding what is your general equation and what is your p-value, but from there, you're just plugging it in to that general form. And then just one other reminder, this p-value is negative because our parabola is facing down, or it's opening down. So anything opening down or to the left is considered to be a negative direction. Okay, so now that we kind of understand the more basic general equation, we are going to add in some shifts or translations. So here you can see that our vertex is no longer at the origin, it's going to be at some point hk. So you'll notice for our vertical parabolas, our equation right here is y equals, so we still have that 1 over 4p out front. Here, our x term is still the one being squared, but here we have x minus h squared, where h is going to be the x value of your vertex, and then on the outside we have plus k. So this looks a lot like vertex form, except instead of having an a out front, we just have 1 over 4p. But it's really interchangeable. The only reason we use this form, the form with the p in it, is if we want to find the focus or directrix. If we aren't graphing with the focus or directrix, this would just become an A and we would use it for a vertical stretch or shrink. Now, if you look at the horizontal parabolas, again, just like with our simpler forms, our y term is the one that's being squared, meaning it's going to open to the right or left. And we have x equals, we still have that 1 over 4p out front. But here we have y minus k. So notice that k is grouped with y. That's going to be the y value of our vertex. And then we have the plus h on the outside. So when it's in this form, here, since it says minus k, that value is going to be the opposite. And then this value is going to be the same. So it's going to just be hk. And again, if this value out front is positive, it's going to open to the right. If it's negative, it's going to open to the left. And p for all of these is still going to be the distance from the vertex to the focus and the vertex to the directrix. So we can use that p value to help us determine our focus and our directrix. All right, let's give another one of these a try together. So here, first thing I'm going to need to do is make sure this is in the correct form. So I'm going to start by isolating y. So I can add 4 to both sides. Then I could divide both sides by 2. So I have 1/2 times x plus 3 squared plus 2. Don't forget to divide the entire side by 2. So from this, I can look at it and I can determine, well, first, I know that it's going to open up or down because x is being squared. If it's helpful, maybe we actually want to write that general form right underneath, which looked like this, to help us determine the different parts. So first, our vertex is always hk, and we're going to do opposite for h in this case, so it's going to be -3, 2. So we can plot that. And because this value out front is positive, and again, x is being squared, that tells us that our graph is going to open upward. So it's going to look something like that. Again, this is a super rough sketch. For today, we're just worrying about the vertex, the focus, and the directrix. So now I need to figure out what that p-value is so I can determine where my focus and directrix are. So let's find our p-value. I'm going to do this over here on the bottom. So 1 over 2 is going to equal 1 over 4p. 2 equals 4p. So my p-value here is 1/2. So I'm going to go, from my vertex, I'm going to go up 1/2 unit, and that's going to be where my focus is. Now, if I want to find that exact coordinate, I'm going to go back to my vertex, and I'm going to add 1/2 to my y value, because that's how you go directly up. So if you add 1/2 to your y value, that will give us our focus. So here we have 4/2 plus 1/2 is 5/2. So that's our focus. Now if I want to find the directrix, I would want to go down 1/2 unit. So I can actually sketch that in. I kind of need to estimate where that is right here. But if I want to define that equation, I could go back to the y value of my vertex and I could actually subtract. So this time I'm going to subtract 1/2, because if I subtract from the y, it brings us down. So 4/2 minus 1/2 is 3/2. It's a horizontal line, so we say y equals 3/2. And there you have it. So again, that p-value is really going to be critical for us. And just remember, if you want to move directly up or down, you simply add or subtract from the y value of our vertex. And there you have it. Okay, let's try another one together here. So here I do need to isolate x. So I'm going to start by adding 24 to both sides. Then I'm going to divide both sides by negative 12. And remember, I'm dividing the entire side by negative 12, so don't forget to divide 24 by negative 12 as well. So for this one, we can see that we're in this form. X equals 1 over 4p times y minus k squared plus h. So remember, k is always grouped with y. H would always be grouped with x. So in this case, I see that we have a horizontal parabola because y is being squared. So it's going to either open to the right or to the left. And if I want to find my vertex, here's h, and I see that k is 0. So my vertex is at negative 2, 0. Now, since this value out front is negative, I know that that means that my graph is going to open to the left. So I can sketch in my really rough sketch of what this parabola looks like. So something like this. Now I need to find my p-value to help us determine our focus and directrix. So I'm going to set negative 1 over 12 equal to 1 over 4p. So negative 12 equals 4p, which means that p equals negative 3. And that negative p-value tells us, again, that we should be moving to the left to get to our focus. Now, we can graph it and see what that coordinate is, but we can also use the coordinate from our vertex. If I want to move to the left 3, what I'm going to do is I'm going to actually subtract 3 from my x value. If you're moving left or right, you want to change your x value. So I know that my focus is going to be at negative 5, 0, which we can see right here. And then if I want to find my directrix, I'm actually going to add 3 to my x value because I want to move to the right 3. And it is going to be a vertical line at x equals 1. So notice if I add 3 to my x value, I get positive 1. And since it's a vertical line, we say x equals 1. So you can kind of use your graph to help you determine what your focus and directrix are, or you can just add or subtract to x or y depending on which way you are trying to move. All right, so now I have one for you to try on your own. So please pause the video and give it a shot. All right, go ahead and check your work here. First, check that you were able to get it into this general form. Remember, when you're dividing by 8, you need to divide this negative 8 by 8 as well. So you can see that this graph is going to open to the right because y is being squared and this value is positive. Then we can also find that our p-value is 2, meaning I would go 2 units to the right for my focus. So I added 2 to the x value. If I want to move to the right, I'm going to add to my x value. And then if I want to go 2 units to the left, I'm going to subtract 2 from my x value to give me my directrix, and that should be x equals negative 3. All right, now let's see if we can look at a graph and determine what our equation is based on our given information. So first, I see that this is open to the right. So I'm going to give us that general form to work with. So we're going to say y minus k squared plus h. So I'm going to start by looking at our vertex. I can see that my vertex, be careful with the scale, here we're counting by 2's. So my vertex is at 6, 2, which means that h is 6 and k is 2. And then I can also see that the distance from my vertex to my focus is 4 units. So that tells us that our p-value equals 4. So now all I need to do is plug those values in. So that will give me x equals 1 over 16 times y minus 2 squared plus 6. So I think for these types of problems, it's actually really helpful to start by writing your general form and then just defining what is h, what is k, and what is p, because then you're just plugging in values. So it kind of helps you avoid some small mistakes. All right, so here we're going to try making some more equations, but here we're just going to be given certain pieces of information. So for these, I actually find it really useful to kind of sketch a picture of what's going on. So here I'm told that my vertex is at 2, 5. Again, it's going to be a super, super rough sketch. So let's say my vertex is at 2, 5, and my focus is at 2, 6. So I can see that my focus is directly above my vertex, which means that my graph will look like this. So that tells me I'm going to be working with this form. Y equals 1 over 4p times x minus h squared plus k. Now, because I'm given the vertex, that is giving us h and k, and I know that this distance from my vertex to the focus is equal to 1, because from 5 to 6, it's 1. So I know that my p-value is 1. So now I just plug those into our formula. So here we have 1 over 4 times x minus 2 squared plus 5. So you have to use the information you're given to determine, what type of parabola do we have? Is it vertical or is it horizontal? And then you just need to determine h, k, and p, and you are good to go. All right, so here in this one, we're given a vertex and a directrix. So I like to, again, just sketch it out to help me visualize. So our vertex is at -1, -4, so super rough sketch. And I see that our directrix is at x equals -4. So it's a vertical line to the left of our vertex. So this is our directrix, this is our vertex. So that tells us that our graph is opening to the right. So I'm going to, again, start with our general form. This one, it's y minus k squared plus h. Here we have h and k, and I can see that this is going to be my p-value right here. So I can see that the distance from -1 to -4 is 3. So p is equal to 3. And we're going to keep it positive because it is opening in the positive direction. So now I just plug in my values. So 1 over 12 times y plus 4 squared minus 1. So remember, we only do opposite for whatever's grouped inside our parentheses. Okay, here's one last one we're going to try together. So here we are given a focus and a directrix. So our focus is at 2, 1. Again, that's our focus, not the vertex. And then our directrix is at y equals 5. So a horizontal line above. So I need to figure out what my vertex is. And I know that the vertex is always going to be halfway between these values. So halfway between 5 and 1 will be 3. So our vertex is right here. So our vertex is going to be at 2, 3. Again, it's going to be halfway in between 1 and 5. And just based on where those my vertex and focus are, I know that this graph is going to open downwards because remember, the focus is always within the parabola. So since it's opening downwards, here's my general form. And I know that my p-value is going to be negative. This distance is our p-value, and I know that that distance in this case is 2. Now, since it is opening down, I'm going to say that our p-value is -2. And then here's h and k, and now all I need to do is plug it in to my general form. So I have -1/8 times x minus 2 squared plus 3. There you go. So again, for me, I find it really helpful to do just a super rough sketch to help me visualize what's going on, to help me determine, which way our graph is opening. And then I also recommend just writing out that general form. So you're just plugging in values for h, k, and p. All right, I have one last try for you guys, so please pause the video and hit play when you're ready to check. All right, go ahead and check your work here. So for this first one, just based on where the vertex and the focus are, I can see that it's opening to the left, and my p-value is going to be -2. So I plugged it into this form, and there's my answer. For the second one, here we can see that our vertex is above our horizontal line, so it's going to be an upward facing parabola. Here's h and k, and I see that this distance is 1, so my p-value is 1. And for this last one, we're given the focus and the directrix. The vertex is exactly halfway between. So the distance from 7 to 11 is 4, so I would just do half of that to the right to find my vertex, which is 9, -6. And then I can see that my p-value is -2 because it is opening to the left, just based on where your focus and directrix are. So here's h and k, and then there's my p-value, and I just plugged it into that general form. All right, so that is all for today's video. Thank you so much for watching.